Hello and welcome back, guys, to this second partial in mathematics. I'm gonna be with you in this time, and it's gonna be a little bit different. I hope you had a good time with your family, sharing time to cooking, sharing time to being talking and doing things we normally don't have the time to do, but it's a good time to share. And I want to share with you many of the knowledge that I have related with mathematics, of course. And for that, we're going to use many internet tools because this is what we have right now. And I'm going to be with you this time, this second partial, and I want to tell you and share with you how it's going to be evaluated and the distribution of some of the contents. So guys, nice to see you again. I hope we have a good time in math, and I hope you're still having the same pretty good attitude in this situation. So God bless you and your families too. Let's start. Okay, here we go with the description of the class. Mathematics, this second partial. How's gonna be the class? Okay, I'm gonna start talking about the evaluation. Some important points you have to consider because of the result I saw in this first partial. Okay, talking about the second partial, there will be 10 weeks of classes from April 20 to June 24th. Every week, you will be evaluated with a homework, online quiz, or an investigation. Of course, in my class, I will concentrate in these three types of assessment, and I'm gonna tell you in what consists each one. In mathematics, every assessment will be evaluated with 10 points. You will present the assessment during the week that is assigned, taking Saturday like the last day to send your assessment. So you're gonna have the whole week to present your assessment. And please try to be punctual. Assessments that are late will cost the half of what it is. So if its assessment is 10 points, you're gonna have an evaluation less than 5 if it's the case. But I'm saying this right now because I don't want to have students that fail in assessments, and you will see the assessments will be very short. An assessment that have 5 or at most 10 questions or exercises like the one you did this last partial. I will try to send you Word documents and in where you just have to like write the letter of the answer, but follow the instructions, please. It's something important for me. Every assessment must be sent in a Word document or PDF, excepting the online quizzes. The online quizzes, some of you have the experience. I think it's a good idea. Use this tool and you will do like 2 or 3 online quizzes. You will see this in a few minutes. If you need to send a mail, write in the email subject your name and grade. Of course, the section 2. It's very important for me because some of you send emails and this goes sometimes to the spam of the email and I can't open it. Or sometimes you send works or homework from emails that are not yours and you don't write the name. This is something important too, that there is a mandatory information you have to write in this kind of works or homework or assessment. Is your name. It's very important. You have to write your name every time. Okay, here is the distribution of the activities I'm expecting to do with you during this second partial. If you see, there are the 10 weeks, and practically I'm gonna work with 3 types of assessments: investigations, homework, and online quiz. So, how's gonna be the investigation? Something you can Google immediately, or something that maybe you will use an online application or an online website in order to solve the exercise or the questions related with that investigation. Homework, how the homework is gonna work. The homework's gonna work like the study guide you did, or like the activity one you did in like the last week or in those days. It's very interesting because all you need to do is solve the exercises and write the answer. Practically, I'm gonna check more answers than procedures. But of course, one of the most important thing here is show me your evidence. So in each of the homework or in each of the investigation, you will send some picture of you doing the exercises as evidence that you were working. Okay. In the online quizzes, you will not have any trouble. It's something that you can answer in your cell phone or in your computer. I will share with you a link, and you will go to that link and you will see how's the quiz. The quiz is very easy. It's multiple, single choice. Sometimes is just write a number, but the situation is something that you can solve. So here you have week by week the activity or the assessment that I want that we do. Of course, each one is 10 points, like I said in the other slide. Okay. In assessment, please follow the instructions. If the instruction requires that you write your name many times, do it, please. Write your name, section, the date, etc. Please, before you send or upload your assessment, be sure that you already filled the information. Why this is so important? Okay, assessments without name will not be evaluated. Why? Okay, because you must guarantee that the work you send is yours. Okay, copyright or no copy. Practically, this is the policy that I want to apply. No copy. If you mistake sending assessments that are from other classes, you should read the comments. I will write in each assessment evaluated, but don't let the time pass. This is what happened with some of the students. Of course, I'm working with 9, 10, and 11th, and I saw that some students mistake on it and send me works from other classes, from physics, for example, or from other classes like symbolic logic in 11th. And it's not my job. I mean, my duty right now is teach you math, and it's not easy at all. But I'm gonna use those tools in order to make this easier for you and understandable too. Okay. How's gonna be the dynamic of the classes? Practically, we're gonna have 2 or 3 classes per week. You will explore a YouTube video or a guided activity or sometimes a Zoom session. I will try to make some sessions with you, and something that happened with Zoom is that it's not available to work with more than 50 students, and practically sometimes stop working if there are 30 persons in that session. So that's why I will use more this session of Zoom in order to attend questions and doubts about the topics, of course. And probably I will make one session like this each 2 weeks. I will share the link, the Zoom link in the platform. So what does it mean? It means that you need to have this application in your cell phone and in your computer, or in your computer if you're using a computer. So this is all, guys, and I'm gonna explain you right now the contents. I will study with you the second portion. Thank you. Okay, hello seniors. We're gonna start with this first. Uno, dos, probando el micrófono, si está grabando. 1, 2. Iniciamos. Yeah. Okay, hello seniors. We're gonna start with this first content, which is related with the chapter of the analytic geometry. But we're gonna start talking a little bit of the Cartesian plane and some of the tools we're gonna need. Okay, dynamic of the classes will be, I'm gonna present you a content, the objective of this content, and development or explanation of what we want to do. some practice, and then some conclusions about it. So let's start. We have next objectives. First objective is describe the coordinate plane. Second one is plot coordinates x, y in the Cartesian plane. I think this is something you already know. Just we're gonna review because sometimes students forget that every time you have to graph first the x coordinate and then the y one. Find the distance between 2 points in the Cartesian plane. Apply distance formula in Cartesian planes, and of course, we're gonna conclude comparing distances. So to review a little bit the Cartesian plane, some people call it coordinate plane, and so some other books or some other bibliographies call it like um, order per read, but it's not that way. It doesn't matter. We're gonna call it Cartesian plane because René Descartes was the mathematician and philosopher who created this Cartesian plane. So here you have, what are the elements we have in the Cartesian plane? We have axes, we have two axes. We have the x-axis and the y-axis. Always the x-axis is the horizontal one and the y-axis is the vertical one. Real numbers, all the real numbers are in those numbers like we have in the horizontal one. We have the positive and the negative numbers, not just this one we have in the picture right now. We have all the real numbers in here. Okay, I know here you cannot see the decimals, but there are many decimals just between 0 and 1, just between 2 and 3. There are many decimals that are infinite. So all the real numbers are represented in here. Remembering that the negatives moves from from the origin to the left are negative numbers, and from the origin down are negative numbers. Something similar happens with the positive values. From the origin, which is 0, 0, the point which is exactly in the middle, goes up in the y-axis with positive values and goes to the right with positive values in the x-axis. Okay. So coordinates are always x, y. Don't change that order. Every time you see a number, don't make a mistake. And for example, if you want to plot or graph the point 1, 3 is the point that goes exactly in the 1 x coordinate and in the third y coordinate. So the point will be here. It's not the same as 3, 1 because 3, 1 will be 3 in the x coordinate and 1 in the y one. Okay, something you already know. Something interesting is about the quadrants, and normally it have 4 quadrants. That's why I call it, they're called like that. In the first quadrant, look how are the coordinates, both coordinates positives. Not the same in the second one. In the third one, both coordinates negative, and in the fourth one positive and one negative. So be careful with this. It's going to be useful later at the moment to understand the conic sections, at the moment to make the graph of the conic sections. So coordinate x and y, respect the x and y points every time the x coordinate go first and then goes the y. It's not the same 3,7 as 7,3. And how can you plot in the Cartesian plane? Just, I'm gonna show you 1 or 2 little examples and that way we conclude. Okay, I want we graph negative 2,1, and to graph this one, we need to look first for the negative 2x coordinate. Here it is. And y in the y coordinate. So there you have where those lines meet. It's practically where the point is. And we already plot the point negative 2, 1. When I say plot, I'm saying graph a point. What about 5, 0? This is more interesting because 0 doesn't tell you anything. And what happened with that point? 5 in the x. So here, and 0 in the y. So you don't have to make any movement to the y. So practically the point stays there, and that's why you plot 5, 0 like that. So keep in mind these ideas, specifically these ones, because those that are x-intercept, you already know them. And other, for example, 0, 4, that will be here will be a y-intercept. So later we will use this idea of x and y-intercept in order to make the graph of some of the conic sections. So talking about the distance formula, which is an older topic we have to study, in the Cartesian plane, you can measure the distance between 2 points with a formula. So giving 2 points in the coordinate plane, not necessarily there, by considering 2 points, x1, comma, y sub 1, and x sub 2, comma, y sub 2, you can calculate the distance between of those. This was a René Descartes discovery, and practically he avoided and eliminated many problems in geometry when he made this analysis and conclude that formula. Is very useful at the moment to conclude some of the relationships that exist in ellipse, for example, or in parabolas. We will see when this distance formula is gonna be useful. So that's why I'm giving you right now the tools you need to understand better later the topics we are gonna study about the conic sections. So how is the distance formula? Very easy. It's practically one transformation of the Pythagorean theorem. And essentially that's what it is that this is the square root of the difference of the x's plus the difference of the y's, each one to the second power. So how that works is very easy. You will see right now with 2 examples. How is this? Here's one example, given 2 points, 1,5 and negative 2,3. I wanted you get the distance between those points. So how can you get it? We're gonna use distance formula. Distance formula just need this, that you have 2 points. So how the distance formula works, you're gonna having the 2 points, you're gonna feed those points in this formula, and let's see how this works, how is this? So considering 1,5 like your first point and negative 2,3 like your second point, you can use the formula. It will not make any trouble if you consider negative 2,3 like your first point. So it will not affect in anything. It's gonna be the same, just that maybe you will have in the procedure you will have some different results or in a different order, but the answer at the end is gonna be the same. Considering this, we have 1,5 and negative 2,3, and trying to fit this information into the formula, we're gonna consider 1 like x of 1 and 5 like y sub 1. Negative 2 like x sub 2 and 3 like y sub 2. So this is what we're gonna do in order to have an order, in order to have a organize better the information the problem is giving to us. So using the formula, we're gonna have the difference of the x's. So x sub 2, which is negative 2, minus x sub 1, which is 1, will be like this, negative 2 minus 1. Be careful with the sign. If here you have a negative number, here is gonna be minus that negative number. Do not get confused the minus of the formula with the negative of the sign the number has, okay? Plus the difference of the y's, okay? Y sub 2, which is 3, minus y sub 1, which is 5, okay? So here you have, all we need to do is make those simple subtraction and or those simple operation, the calculator. We're gonna get next the square root of the addition of negative 3 to the second power plus negative 2 to the second power. Probably if you choose negative 2,3 like your first point, you're gonna have those in different position, probably, or maybe other values, but at the end the answer is gonna be exactly the same. So this is what we have, and negative 3 to the second power. Be careful at the moment to do this in your calculator. If you write this without parentheses, you're gonna have a negative answer, and that's false, because here you're multiplying negative 3 itself twice. So you're multiplying negative 3 times negative 3, which is positive 9. Same happens in here, okay? That's why I choose this example to remind you what happened with your calculator at the moment to write expressions like this. I mean, if you just write negative 2 to the second power without those parentheses, you're gonna have a trouble. You're gonna mistake on the exercise. And you're gonna have here maybe a negative answer, and probably at the end you're gonna have a negative root which doesn't have an answer in real numbers. And as I told you, the coordinate plane works with real numbers. Okay? So at the end, the distance between those points 1,5 and negative 2,3 is the square root of 13, which approximately is like 3.6055 units. It can be centimeters, it can be meters, it can be kilometers. Remember that these points represents a location. And practically what you're saying in here, that square root of 13 is the distance between those locations. Okay? This is an interesting idea, useful in physics too. So how is this in the Cartesian plane? We're gonna see it better, and just I'm gonna say, and be careful with what I'm saying. You don't need to do the Cartesian plane, to be honest, to understand, or I mean, you don't need to graph those points in the Cartesian plane to get the distance, but just to show you what it is, here is the Cartesian plane. So the points we have were 1,5, here it is, 1,5, and the other one was negative 2,3. So negative 2,3 is like in here, it's exactly there. And practically what we found is the measurement of this segment we have in there, which is square root of 13. Okay, this is what Descartes did many time ago, and it was very useful in geometry, because in geometry they don't have measurements until Descartes makes the coordinate or the Cartesian plane like we know it, and start to give numbers to the ideas that doesn't have a measurement. Okay, here's another example. I'm gonna give you like 10 seconds in order to apply the formula or to see what happened, and I'm gonna explain you this very quickly. So 10 seconds from now. Okay, you have to choose one of those like your first point. This is the first thing. And doesn't matter which one is your first point. I'm considering right now 0,4 like the first point, and negative 3, negative 1 like the second point. So you can use the formula now. 0,4 will be your first point, means that 0 is x of 1, 4 is y of 1, negative 3, negative 1, negative 3 is your x of 2, and negative 1 is your y of 2. Applying distance formula, we see the difference of the x's, so x of 2, which is negative 3 minus 0, will be here, and the difference of the y's will be negative 1 minus 4. In this case, this is what we have, and let's see how that works. Operating those simple subtractions, we got those results. Using the second power in each one, we have the square root of 9 plus 25, and 9 plus 25 gives you 34. So the square root of 34 is the distance between those points. It's like 5.8309 units approximately, and by that way you get the distance of those points. Okay, easy. I think it's very easy. Just practice a little bit, and for that we have this short practice, and then we conclude this first class. So it's not complicated. So I'm giving you here 3 points. 4,6, your first point, or your point. 0, negative 3, another point, and negative 1, negative 4, other point. So I'm asking you what's the distance between piece of 2 and piece of 3, or second point and third point. So make your procedure, make your analysis. You can stop the video and solve those exercises. Of course, I'm gonna give you the answer, but I wanted you to try, because this is about trying. Math is about trying. So here is the option C, and here is the option C too. Make a mistake. But don't worry about it. One of these 3 is the answer, and one of these 3 is the answer between the distance of between P1 and P3, those points. And I'm gonna show you this in 5 seconds. Okay, here you have the answers. In both, the answer is letter B. Oh, but now here I repaired the mistake, sorry, in the other slide, but the right option in each one is is the B. You can check it. There is an online, many online tools that can help you. You can see it in your computer. I think not in all the cell phones, but you can write like distance between 2 points online, and you're gonna have like online calculators that can solve this very quickly. Of course, I want you to understand how this formula works, because then it's gonna be useful. So to conclude this first class, the coordinates works always the x coordinate first and then the y coordinate. Please don't lose this idea, because it's too common students mistake with this simple and basic idea. You don't need to grab the coordinate in the Cartesian plane. In the Cartesian plane, in order to get the distance between those, just apply the formula. The points will be needed later at the moment. That's why I'm review how to plot points or how to graph points in the Cartesian plane, because it's gonna be useful later when we make the graph of some conic section, which is practically the topic. This tool right now, this is just a tool right now we're gonna need later. You can choose the first point and it will not change the distance between the points. So it doesn't affect your choosing your selection, I told you. And it's one of the conclusions too. And the last conclusion is that Cartesian plane helps to measure the distance between two locations. And practically this last one is one interesting. Maybe you will have an investigation related with that one. Very simple, something you can Google. But more interesting is see the shape of the conic sections we will study later. I think something you did the last year, and you have an idea about how it is, but now we're gonna see how to do it, how to graph it, how to build it, and how they are, and essentially the elements they share and the elements, the specific elements they have. So guys, thank you for your time. Thank you a lot for your time. The classes will be like this, or probably I will share another YouTube video, but right now this is what we're gonna prepare for you. And God bless you, and thank you for your time again. See you next time.